hello, come on.
There we go. Okay,
Yeah, there
super.
we go.
So welcome again, Prasad, and yeah, let's hear about what you agreed to talk about today, and it's just going to be an informal session. We'll have some Q&A throughout.
Excellent. So I will take that cue, Alan. And so can I start my presentation as part of that? I mean, it is informal. I mean, I'm calling it a presentation. There are a few slides, but predominantly we would like to showcase something that is working as part of a demo. And so you can put me up to all the claims that I'm making as part of the presentation, you know. So that
makes sense.
Yeah. All right. So if I can share my screen, can I do that? Yeah.
Should be able to.
Yeah. And just so again, I mean, if anyone is joining late, I mean, I'm joining from India. It's late night. That's not the issue, but it just so happens it is Diwali, and so it's a noisy festival. And so you might occasionally hear some crackers going off. So don't be alarmed, you know. And in case if you're not able to hear, please ask me to repeat. I'm more than pleased to do that. Okay, I am sharing my screen.
There we go.
Okay, are you all able to see my screen?
Yes, I'm seeing it.
Yep, me too.
Okay, so as Alan has started off, for starters, Alan has requested to see if we are able to present at this, to your group. And we are more than thrilled, as I said earlier, and we were so looking forward to to this day. It just so happens it coincides with a noisy festival on the side, so hopefully that doesn't come in the way. The topic of the presentation is TextDistil, is a product that we have worked over last 2.5 years or so to develop. What it does is it takes in text as input on one side and generates semantic triples that can be readily ingested into a vendor triple store. That is as simple as it gets. And text processing, is kind of, fairly involved. And that is what we would like to kind of, showcase and discuss and hopefully do a good demo at the end of the discussion here. Okay, so I'll go to the first slide here. I have kind of introduced ourselves as a company, but I would say so here, bring it up again here. We believe in the company this one thing. I mean, this pictorial kind of sums it up. We think language and knowledge are two sides of the same coin. And we are some of us are linguistic, come with linguistic background, computational linguistics at that, some AI and things like that. But over a decade of experience with plain RDF and SPARQL and things like that. But a lot of the action has begun for us in the last 3 years, I would say, essentially when we started looking into text. And that was synonymous with when the neural language models started to appear and be accessible for, and then all these cloud clusters were available for, routine startups that were trying out different things. And so our mission is to bring out the knowledge buried in text into the enterprise knowledge graphs, because we are convinced there is plenty of knowledge that's kind of just sitting inside the text that is accumulated in piles within the enterprise that doesn't see the light of day. There is plenty of it. And I think the right technology is what the moment is waiting for. And I think we probably have one version of something that works in production environments. And I'm pretty sure there will be many similar such tools, or and we may be probably be able to do with newer releases more and more of this stuff. That's in a nutshell. That's our background. I'll go on to talking about the TextDistil product itself. It's a language processing pipeline. It extracts knowledge, which all of us know. It's entities, relations, events, and so on. So-called NERs and things like that. But relations is a very tricky thing. But that's one of those things that we think we have something working really well even in production environments. We extract topics and keywords in narrative text all that aside, sentiment is something that is we haven't gotten to that, but that's hopefully we will have a chance to address that in future versions of the product. Given that TextDistil works with tons of these documents, hundreds of thousands of these documents, it was a good idea to kind of have a corpus management system. And so we have a companion module or a product called iCorpus that manages all these documents that would need to be processed through TextDistil. And this module iCorpus has a semantic layer. It provides a semantic index that is searching more than the text, like the keywords and such. It's by search by topics and so on. And it's all underneath it all. It is managed by Elastic, and so it's fairly scalable to large volumes of text. That's in a nutshell TextDistil. And just continuing on what it is, getting into the detail of it a little bit, it extracts lexical and semantic structure in the narrative text, and with a goal to extract entities, relations, and events. And it takes help of a bootstrap ontology, and then linguistic rules, and there is a whole bank of classifiers. Neural language model ensemble kind of provides that classifier bank, and then we iterate through initial versions as we are trying to figure out how the extractions are working. And then the ontology gets fleshed out, the domain knowledge kind of gets involved, and that gets fleshed out. Linguistic rules gets tweaked, and the classifier thresholds, they get tweaked. And so all of that, one way or another, would stabilize over time. Hopefully, when we process like 100,000 documents of 1,000 words at a time, for example, probably first 5,000, 6,000 documents is what would probably representative of the task involved in stabilizing the pipeline with all the configurations necessary to kind of freeze the ontology, the rules, and the classifiers. And the goal of the TextDistil itself is to generate these triples, that conform to the ontology that a downstream application is expecting. And these triples are mquads, and they can readily be ingested into any vendor triple store.
So Prasad,
Yeah.
if I was a client interested in TextDistil,
Yeah.
and I was thinking about different use cases that might be suitable to try this out, you mentioned what was it, 5,000 data sets to stabilize the ontology? Is that right?
5,000 document in a 100,000
documents.
file.
I'm sorry.
Yeah.
5,000 documents. So are those documents sort of all representative of a single use case and a single pain point?
So typically, I mean, so you want to give some representative stuff that you are likely to see in the unseen data, right? So in 100,000 news articles, for example, that's what the example I was trying to shed light on. These articles are, let's say, 1,000 word, 500, anywhere 300 to 700 words in general. For example, this one particular use case is in my mind. And so we would need anywhere from 3,000 to 5,000. That's when we have seen the TextDistil pipeline stabilize, and it generates a fairly accurate, it crosses more than 85% accuracy in terms of what is expected in the downstream triples. And at about 1,000 articles, for example, it would generate, maybe it is 60, 70, that kind of a thing. And so you are looking for outliers and more of those to feed into the learning process. And so that's why I quoted those 500, but that's not a hard and fast rule. So different corpus, if you take effort to identify all the extreme cases, and then enough of those, enough number, so to speak, then I think we can stabilize it a lot sooner. Does that make sense?
Yeah, it does. So if you have some internal applications, each with their own database, but you don't, a typical enterprise problem is trying to get access to the data. It sounds like you really need to tee up the data accessibility before we even get started with LeadSemantics, correct?
Right. I mean, if you are
Yeah.
talking about, the documents and, things like that. Yes.
Yeah.
Surely.
Okay.
Yeah.
Okay.
Yeah, the related question I have is document decomposition. So if I have a PDF document, I'm assuming you need something prior to your software that takes that PDF document and breaks it into sentences that you're going to feed one sentence or one paragraph at a time.
Surely. There is a pre-processing module within TextDistil, but the process of accessing PDF, there may be some limitations there. I mean, we need plain text to be accessible. And we like text as it is available in terms of its demarcations, that kind of, gives cues about paragraph, delineations and so on. So that, we can build up our text blocks, so the scope for our, language comprehension module, does it need to be at a sentence level granularity, or can it be at a paragraph level granularity? Can it be multi-sentence or multi-paragraph? All of those things, they're all considerations that would go into how we pre-process the, certain, that given corpus.
And just one more quick question.
Yeah.
What was the key insight that really inspired TextDistil and it's the way it does this? Is there what's the value prop that you could pitch in an elevator regarding this?
So one important thing is that text has a lot of knowledge that enterprises would can take advantage of. So that's one important thing. Now extracting text out of knowledge out of text is hard. I mean, just using neural language models is not enough. Just using linguistic rules is not enough. You have to have a right balance of these things, and that kind of goes with a little bit of playing around with what it is. And most interesting thing is that ontology plays a good role in automating such a messy pipeline, and that's what is unique about our tool, is that it mixes ontology, the rules, the linguistic rules, and the neural language models. And then it kind of downstream the outputs, and I'll be able to show in the demo, the output can be directly fed into an application that is expecting the data. So in other words, your text is now totally structured and available for downstream applications once TextDistil is in the middle.
Okay. And we'll get to the demo in just a minute. Matthias had a question regarding the text data you've been experimenting with. Could you describe them? Full sentences, keywords. You mentioned new articles. Have you experimented with specific domain-specific and technical content? I'm assuming you've experimented with all sorts of content. Is that correct?
Yes. And we are in production as well. I mean, and so I can pull up an article, a typical article. It is regular stuff. For example, this is. Are you able to see my screen?
Mm-hmm.
So this is a newspaper article that is fed to us by Factiva. It is a Dow Jones company. So this is a newspaper article. So these are running sentences. This is out of let me see. This is Bangkok newspaper, English newspaper, and these are running sentences. Or does that give a clue?
Yeah.
And similarly, we have processed, SEC filings, 10Q, 10K filings. At least a group is playing with TextDistil and trying to extract specific information out of SEC filings by companies.
We have a number of people from pharma and other technically oriented verticals. Have you worked with pharmaceutical data,
No,
medical
we have
data?
played with medical data, I would say, pharmaceutical, biomedical data.
Mm-hmm.
For radiologists, their related document, it's we just played with it.
Okay.
Yeah. But mostly, in production, it's about financial data and news data, crime-related information, narrative, bulletins and so on. Yeah.
Okay. It'd be good to know, say, some example customers and where they sit in the business world.
Yeah. So can I move? Can I?
Yeah, if
go
you want to
on?
go into the demo, that sounds good.
Yeah, I mean, there are a few more slides, so I was just going to
Okay.
go through, and please feel free to ask these questions. I mean, so yeah. So this is and the tool itself is parallel and it is scalable. I mean, it's highly scalable, we would say. Given that it processes one document at a time, and so you can literally have as many the compute cluster to handle as many parallel as possible. If you have a certain number in mind in terms of documents per minute, that's the kind of a thing. Of course, the ontology and all of these things will kind of weigh down in terms of how much processing is required. So given TextDistil is a server-side process, and it's a pipeline server-side process, and as pipelines go, this is pretty much underground, so there is no user interface for TextDistil itself. It's completely server-side, runs on its own. You feed all this. Once it's in production mode, it can take on these tens of thousands of documents and produce this graph on the other side. And so the initial process of making sure it is production worthy, the configurations of the pipeline are production worthy, we needed a debugger of sorts. And so we developed this companion tool called FactCheck. We call it FactCheck. It's like a visual graph, but the key thing is that the nodes and edges, when you click on them, they point back to the text from which that edge was computed, so to speak. So that gives the analysts and the data scientists to kind of clearly see if a certain rule is working as so at least they have suddenly the view into the the underbelly of TextDistil itself. And so that has been extremely useful. I mean, now we are packaging it together, and that's how it goes. It serves as a debugger for TextDistil. So in fact, the demo is through FactCheck that we'll show you that. And if I can go to the next one. So as the examples, Alan, you were saying, so one group is trying out to try and extend a business graph that holds legal entity information of businesses. So this LEI graph, I'll go to the next slide. So this LEI, it stands for legal entity identifier. And this graph holds various properties, 100+ properties. Typically, all the KYC information. It's like a directory graph, so to speak, right? And so the name, the address, the CEO of the company, the head office, and things like that. It's on and on. And so some of that information is likely to get old, and so there may be new information that is available on the market through these news channels and so on. So this group is trying to see if they can, as part of the directory search, if you can plug in the news of the day that is relevant to the company somebody may be searching for. That is the kind of a use case that they are working for, and they're using TextDistil to do that. So in that context, I mean, reason being, knowledge is always changing, and so in order to keep the graph current, you do want to kind of tie into these sources that carry these changes. And text is a best source of the change, and language. When I say text and language, they're interchangeable. And text to knowledge graph is a practical technology. So the way they've been using, and in this example, I hope you are able to see this. I can't zoom in any further, but this is part of that LEI graph of Biogen, the company. This was probably in February or some such time. I just picked out this slide from the other presentation that they were doing. And this is the LEI graph, the green part of the graph. And this blue stuff is extracted from a news article during that presentation that was happening. And that day or prior week, Biogen announced Alzheimer's product, and so there was some interest in terms of various things that people are interested about companies, the stock price, the price of the product, and on and on. So the relevant triples were pulled out and attached to the directory information in the business graph. And so that seemed a pretty interesting use case, and that's how they are trying out a few things with that. So that is one use case that we know of in the business area. And then another group is using or trying out things of trying to extract SEC related information using Edgar and TextDistil. And in this case, the example as it goes is to kind of, take on these 10Q documents. I'm not sure if it is visible.
Yeah, well, I think people are familiar with what a 10Q or a 10K is.
Yeah. So I mean, so the interest for these people, this is a financial analyst group. They wanted to, in this particular use case, they were trying to see if there was some kind of a disclosure related to how much money Apple, actually, this is as an example, Apple was what was considered for this sample run. How much money was being set aside for repurchasing their stock, and it probably had some kind of a Q value in terms of the company, is it spending the money in the right place, or are they planning to save it for growth investment and so on, whatever the extraction is what we were interested in, and so TextDistil was being tried out. So these are the two examples I have, and I wanted to kind of jump into the demo where we show you show you the document, and then see the extraction live as we discuss. If that's okay with you all, I mean, I can go on to the demo.
Yeah, that sounds good.
Yeah, okay. So I will switch my screen here. And go here. So this is the document we had. Yeah. So we have this user interface tool that I just spoke about, the fact check. It's an NLP panel. I will bring that up and connect to a regular document and see if we can process the document right here. Show you, bring this up.
There's a firecracker in the background there.
Yes. Yes. I mean, in case something goes off, I mean, towards the end of the day, folks kind of save up the big ones, So I would not be surprised if suddenly there is a really noisy thing that just goes off.
Okay.
So please be warned.
Okay.
Yeah. So this is the NLP panel, as I said, we call it the fact check. And this has the two panels here. Text block, the text block that we want to process through TextDistil appears here. And then once processed, the extractions go into an RDF store at the back end. A SPARQL query gets applied to it. And then the results of that are shown on the right-hand side in a connected view. Yeah, so I'll just showcase, we can start off with this document, for example. So I just showed you, this is the article, news article, plain running news article. So except that it's not PDF, so even if it was PDF, we would have liked the text out of it because we access through the text. So this is the text. So I will upload the documents. So I have 3 documents here. So I mean, for starters, I'll just start off, load all the 3 documents. It's processing. The entire pipeline, I'm not running the entire pipeline, but it would take some time. So there is that pre-processing stuff that has happened, that has segregated into text blocks that are relevant for this type of text. And so the text has already appeared on the left-hand side. And on the right-hand side is the graph that is the result of the SPARQL query that is applied to the backend data store where the extractions are stored. And I have brought in 1 document. I think there are 2 more documents. These are all the predicates that it detected, or it computed rather. I added that as well. I'll go to the third document. There is a third one. And I'll pull all of that. And close that. So if you can see the screen here, so I can bring up the node labels and edge labels will be messy. I can bring that up as well. I mean, later on, I was going to go into one document and, really explore together with you all, So, but this is how it is. On the left-hand side, the 3 documents that we loaded have been segregated into, in this case, I think sentences. And then, so it's running documents. There are as many as 76 text blocks. So each text block is like is the scope of one comprehension, if you will. I mean, that is the scope of comprehension at a time. The context and all of that through the article is carried for each text block, and then together they are sent through various classifiers and linguistic rules and all of that, and then the predicates are computed, and all of that stuff. So that's what we will see on the right hand side. So here, you can go up here and click on various things, and for example, I clicked on one text block, it highlights the corresponding text block here, and so we can explore that. We will do that with one document. This is just too messy. There are many more things that I could have brought up. It will only be messy, so like edge labels and so for example, I can do all that. I mean, that would only be glitzy, but just so you know, we can load as many as the browser supports. The TextDistil processes nonetheless. I mean, this is a medium-sized ontology that we are working with, probably about 25 major concepts and about 70 plus sub-concepts. And there are plenty of predicates that are all computed. None of them would, many of them would not appear in the text itself. And so that's what the entire promise of the TextDistil is. Any questions just looking at this? Because each graph, I will go into one document specifically and we can explore more in detail. At this point, are there any questions?
No, it seems pretty clear. Folks, any questions for Prasad at this point?
So
I know there's some more general questions, but anything specifically on what he's showing us?
Yeah.
Well, just very briefly, when we say that the ontology is driving the extraction, does that mean that all of those predicates here are defined in the ontology? What is defined in the ontology that we see here, and what is not in the ontology?
Right. So the ontology is a queue for us. I mean, so we use ontology, the predicates listed in ontology as one end, as a target, but the language that is extracted, the terms that are extracted from the text may not map one-to-one, even if you try to calculate the relation between the NERs in a sentence or in a paragraph. And so we compute, the meaning, semantic similarity between the predicates and what we find in the text.
Okay, I see. Okay, thanks.
Yeah.
Is there any probability assigned to the fact generation, like confidence?
On the facts itself, yes. I mean, definitely, because once we settle on any of these things, like all the text that you are seeing is literally output of a highly probabilistic set of components that are kind of mixed up with the entire, within the pipeline. And so we come up with the final, some score that says, it's 55%, whatever the score. I mean, so we tweak it, but most of the time, because we are doing it in production purposes, folks want it for a specific output, that they can, feed into another application. And so we try to match it, and several of them fail, Many of these, I can't say all these extractions are correct. There may be many that are wrong, some that are wrong for sure, and so,
Yeah.
And that, so it's an iterative process. And so when you go back to correct them, that's when we look at the classifier, the thresholds. I mean, do we tweak this to be the NER? Is it the right classifier that threshold that we are using?
Yeah. So is that confidence reflected in the final graph, or is it things are either in the graph or not, dependent on a certain.
So it is not directly reflected in the graph, but we would have to see, because there are several classifiers that are running in the background, you know. So we can, but an analyst would look through, you know, they would go through the pipeline and say, okay, the first time after pre-processing, there is a certain confidence level, and so we pushed it through. We thought, you know, this was the bucket it fell into, and then moved further and so on. And so it ended up computing a wrong thing, for example. And so they would have to go through and, you know, maybe, but there is no one single score, so to speak. We can come up with a score, but we try to forcibly, through rules, fit into the customer schema at the end. You know, and so when it fails, you know, there is a process going back to kind of, you know, correct all these classifiers.
Yeah. Okay.
Yeah.
Yeah.
Makes sense.
Also, you mentioned that the text block is the scope of the analysis, right? Each one.
Right. So the analysis, that's a little bit, little more involved in that. This is the center of the analysis. It's like the anchor of the analysis for that particular comprehension that you know, the system is trying to do. We go few blocks above, few blocks below.
Okay, I was wondering that, and like, because you know, whether it's pronouns or other things.
Yes.
Is there,
Yes.
you're
Yes.
able
Yes.
to connect that.
Absolutely. Absolutely. And in fact, you know, so in this particular case, this is a crime related, you know, application from regular news channels. And so the language is very general. And so there is a mention of general crime at one time, and then progressively through the article, it kind of develops, it kind of takes on new attributes. The crime definition itself kind of, you know, takes on new attributes, like the perpetrator comes about and the place of the crime comes about. So we kind of, you know, keep the context rolling through the analysis as we go down the article.
Great.
Yeah.
Thanks.
Yeah.
Yeah, that sounds good, Prasad. We
Okay.
can go on to the next step here.
Okay. So I wanted to go through one document. I mean, you know, so that it's, you know, we'll stay away from all this color. I'll reset this. I'll load one document so we can kind of, you know, go through a little more closely. So this is, you know, there are 25 blocks in here, and okay. So it is, and also I will remove, oops, certain predicates. You know, we have for account, I'm sorry, of all these predicates, some are kind of, you know, they kind of track a lot of information that helps for debugging. So I removed some of those. We can pull them in later on as necessary. That's for plainly for analysis. So I'll bring in the edge labels, node labels, toggle arrows. So this is the document is this. You know, Myanmar, it's in Myanmar. This particular news article is in Myanmar, where there's a lot of conflict related crime that is happening. And so we are kind of working on some things here. And as you can see, these are different icons. This is an icon for an event. I'll just introduce the different icons and then we can get into the details. So this particular thing is an event icon. This is location, as is obvious. This is just a data type property. This is person. And there is, this is date time. And then few more, if there are any, we can see if there is anything that is kind of lurking here. Yeah. And we can use any number of icons, you know, so all this green stuff, if there is a type associated with it, we could have easily attached another icon, you know, and this is for the demo, and we haven't really taken care to bring on all the different types of icons that would probably make it much more easy to follow.
Do you mind looking in more detail in some of the events? Because
yeah. So let's look at, so for example, so I'll click on this. It is going to this central text block, so you can see, you're all able to read it, right? Is the font enough? Are you able to read it?
Yeah.
So these are, some Lura 20 and Sinan 21 were volunteer teachers working in Quanka village. And on the night of January 19th, they were raped and stabbed to death with knives, allegedly by a group of soldiers, right? So that is, there is an event in there. And so clearly it connects to an event here. And there is plenty of information that is brought into this. So if you look at, this is corresponding to this text block and this event, stabbed to death, is a some kind of a, I can increase the font. This is SV HR violation. SV is the sexual violence, is a HR violation, stabbed to death, like that. And then this particular event itself has, this is the victim. This person is somebody, Sinan, yeah.
Is that part of the ontology that was provided to the tool, like this notion of a victim? Because there is nothing that says victim in the sentence, right?
Exactly. So the ontology kind of, talked about an event. The Bootstrap ontology has some of these terms. Yeah.
So something like victim and perpetrator or whatever, like that would be part of the Bootstrap.
Exactly. Yeah.
Cool.
So, yeah. So, I mean, so we can follow these things like, the location is a village and, there is a village. So we didn't figure this as a village. So so that may be something to look at. Oh, I see this, Quanka. So these two together should have been the village.
And as a user of the tool,
yeah.
So two related questions. First, do I have to write some handwritten rules to do this extraction? We depend. Can I, if I wanted to, even if you don't have to? Yeah.
You could. I mean, as a user, I mean, definitely, because there are plenty of linguistic rules actually. So we extract a lot of nominals to kind of figure out, are we missing anything, like that. So there are a lot of rules. Some of those nominals will clearly not be qualified because there is a flood of information that kind of qualifies, and you want to prune it out so that the computation kind of doesn't veer away.
Okay.
So these are all the things. I mean, many of these predicates are not. I mean, many the predicates themselves don't even. You may not even find them, but we take advantage of the verbs clearly if there is anything there.
It seems like it's like there are verb phrases that become essentially
they are candidates, but they can throw you off. They are not necessarily will guide you to the right predicate.
So I'm wondering, how do you get to levels of abstraction with multiple documents? And then is this a tool that a domain expert who's not a technologist can take advantage of to help the system out with recognition and disambiguation?
The domain expert can guide I mean, given the tool itself is not in a finally packaged form, even though it is able to process, it's able to process, hundreds of thousands of documents, that's where it is. But it has to be managed by skilled guys at the back end, skilled folks at the back end.
Right.
Because these linguistic rules and the classifiers, they're all a little bit, we need to know, how much to go into the linguistic side of it, and, when to, tweak the models. And these models are not reliable as big as they are, like T5 and all these things. So they are useful, but, so they can really throw some odd, and so a proper skilled guys probably are required. And
Yeah.
if on the domain side, on the customer side, if there is that, but domain knowledge kind of really tells us, how the ontology, how far to go, how far to interpret. We use, WordNet to kind of expand the vocabulary, right? Initially to do the search. And as we do that, are we going too broad, too low? I mean, all those things can be corrected through someone that has a proper domain knowledge.
So Mark, I'm thinking about semantic arts and your work with Alan Michaels, for example, and how the product classification ontology could be used in conjunction with GIST, for example. I mean, is that the sort of the angle you're thinking in terms of making this useful from your perspective? Mark Wallace.
Okay, I wasn't sure. Yeah, I have not worked with Alan Michaels directly on this. I don't know if there's someone else on from Semantic Arts who's particularly looking at, leveraging the text extraction at this point.
Okay.
I mean, we have multiple clients that are, that are interested in such things, right? Lots of people are. How do you pull this in? I think that's why, all the questions we have, how ontology driven is it?
Yeah.
How do you get confidence? Things like that.
Yep.
Any specific domains that you are all focused on?
Well, Ram was asking about pharmaceuticals, and he's asking how long does it take to train your system for a given domain? So,
yeah.
Ram, do you want to join in with the conversation here?
Yeah. So what's the effort involved in training the system for a totally different domain in terms of ontology, domain ontologies that you take, you train? You also mentioned some NLP engine behind the scene, and how, what kind of training required in terms of training that NLP engine, any kind of indexing that you're doing, and if you can comment on the effort involved in those, so that, if in case there is some pharmaceutical or biotechnology or healthcare, life sciences terminologies and wording, if you need to bring that semantics, how do you do that?
So one thing is, if you all have, so ultimately when we are ready to kind of, start configuring the pipeline, what we look for is a good taxonomy that really helps us manage these, word clouds and, all these exploding sets of words. If there is a domain specific taxonomy and then a bootstrap ontology, but then a general domain knowledge around it, as we, run the pipeline through the initial configurations through first sets of documents, if there is domain knowledge that tells us that, the right way or wrong way, the extraction is right or wrong, that would kind of drive the entire process way faster. And the new domain, again, the novelty of the domain is kind of built into this ontology and the taxonomy for us. And TextDistil itself is a domain agnostic, and the NLP engine is plain linguistic in its essence. With NLP, of course, we have to use NER extraction tools specific to the domain if there is one. Like biomedical, we use Spacey biomedical. There are a few others that are there. We haven't done any production work in biomedical side of it, although we played somewhat with that.
Thanks, Prasad. Appreciate it.
Yeah, and Doug, you had a couple of questions. How is stability measured? Prasad, you mentioned the the stabilization that takes place, how is that measured?
It's like, we run, it's like, for example, in 100 articles and 75% above, the different types of ontology elements that are to be extracted. And, there is a threshold beyond which if all extractions are happening, it's a green flag to kind of go forward with it. And of course, the first version of this graph, it will have, even though it is worthwhile, it is producing, I can show you the extractions through the RDF, triple store as well, what it produces. And then, if there is errors and mistakes and so on, you can go in there and correct them, so clearly the specialist would know, is 75%, are we reaching that threshold as we are running through these documents, next 10, next 100, are they producing the right extractions?
So Doug, you had another question, you want to join in?
Right. So I was wondering, so in the ontology, do you support any kind of ontology? So if we were to put an OWL-based ontology in?
Yeah. Typically because the surface of the ontology should match with the surface mentions on the text, right? So the depth of the ontology probably doesn't have too much of a role to play. But by that, what we mean is, the surface of the ontology, all the classes to which the subclasses and the class instances appear in text is what is of interest. And so typically the extraction itself is shallow ontology driven, in that sense. And of course, the entity linking phase requires a matching support. Because deep ontology will probably constrain the extraction process, especially if you are, trying to fit, extractions to a very highly, instrumented ontology, if you will.
Well, okay, so just as a follow-up question, for instance, in your example, you talked about an individual sin non.
Yeah.
Would an ontology, so you have, it appears to be identified as an individual, but do we know that, for instance, that it's a person individual? Is it a living thing? Do we know that? Or is that?
Yeah, this is the classic NER system would identify this as a person, given the way it has been, it has manifested in the text. And 20 and 21 is the age, so that's the.
Okay. So in the triples that are produced, there would therefore be a set of assertions to the effect that this individual is in fact a person. I mean,
right. Yes. So that is the next phase of confirming, and all this information. Like for example, so all this data goes in as triples, right? And so that's when the ontology layer and then the rule application and reasoning and all of that can be done in that phase.
Okay, downstream actually from the extraction.
Correct.
Okay, thanks.
So we only have a few minutes left. Any further questions?
I will show one more thing, so that
okay.
it kind of, ends the pipeline, the final output, at least before the extraction kind of, hands it off to the next phase of, reasoning and, as the other gentleman was asking. So for example, all these extractions go into, in this case, we are using electrograph. So I will go to an instance of the electrograph where it's loaded. And we can apply the query. I just made up that query here. I think this is. Okay, so this is the results of the query, we are trying to bring out all the NER type, which is here, it is crime is the main goal. So SV stands for sexual violence. And so there was an event detected, and the event time detected, event place detected, and so on. So many of them will be redundant. And so this is the phase where the reasoning and rules layer will merge them to the exact, specific ontology expected events. And, we have that phase also, which I cannot show you here. So for example, in this case, this person with the same age, it's repeated, but something here is different, so it was Quanka and village, and and something is different, and that's how it shows up as a different row here. But it's actually a single event, and so the rules layer, which has some reasoning elements into it, will converge them. It'll all end up as 3 or 4 actual events, that people can point to and tie event plays, the victims, the perpetrators, and so on, whatever is there mentioned in the article.
So you're using a lexicograph in this case. Have you been working with Franz and Jans Osman on their event-driven approach?
Not really, not in this case. Although we work with Franz; they are our partners as well. But not in this case. We are just using their version because the client is, using it.
Okay. So this has been a really good discussion today. Prasad, thanks so much for unpacking this for us. It's a level of detail I didn't see in the other one, and it's really interesting what you're able to do. Folks, if you have any follow-on questions for Prasad, I'd be happy to share them with him. And in general, Prasad, I'm assuming people can reach out to you directly with some follow-ups.
Yes, more than pleased to answer, interact. My email address is, I can share the presentation, Alan. Is that
okay?
Can I send you the presentation?
Yeah, please do. We can circulate that, and it has
Prasad, the email address.
Prasad Y at LeadSemantics.com. Is that your email?
Yes. Yep. That's
okay.
It. Yep.
All right. Super. Thanks again for doing this on a late night where you are and during a holiday. How long's the holiday last?
Well, I mean, it's actually this noisy thing is day long, but the festivities go on. I mean, they started probably about 2 weeks ago. It's a holiday period. It's the biggest holiday period in India. And there is another festival 2 weeks ago, called Dasara. And so between that and Diwali is the festival period, so folks are kind of, they can take time off, you are culturally insensitive if you don't allude to that and accept that. Yeah.
Well, enjoy yourself and enjoy your time off and time with family. And we'll definitely be back in touch. This has been really helpful for us to see what you're able to do here.
Thank you so much. And again, thank you so much, Alan, for reaching out to us. As I said, we are thrilled to present and this wonderful interaction. And this looks like it's a pretty knowledgeable semantics kind of a group. And we've been looking forward to dealing with groups like that.
Yeah, it's good to get all these folks in a room, even if it's virtual. So we'll try to get them to talk more next time.
Yeah.
Thanks everybody for joining today.
Thanks, Prasad.
Thank you.
We'll see you next month.
Yeah, I'll send my presentation, Alan. Thanks.
Okay, absolutely. Please do. And I'll be in touch with you.
Thank you.
Thank you, Prasad.